less power than what we started with. So we're going to start out with x to the power of 4. So this is 1x to the power of 4 plus 1x to the power of 3 plus 1x squared plus 1x plus 1 with no remainder. It's kind of a crazy problem. Simple, but it can get confusing, particularly if you forget to put in the zero terms. So now we're going to move to the next synthetic division problem. I notice it goes from an x cubed to an x squared to an x to a constant, so I don't have any zero terms I need to put in. My r value should be the opposite of minus 2, so it should be plus 2. My coefficients are 2, negative 5, 4, and negative 4. I'm going to bring down my first coefficient, and every time I have something down here, I multiply it with r before I put the product here. So 2 times 2 is 4. Negative 5 plus 4 is negative 1. Negative 1 times 2 is negative 2. 4 plus negative 2 is 2. 2 times 2 is 4. Negative 4 plus 4 is 0. So I have a remainder of 0, no remainder. I'm going to start out making this the coefficient of one less exponent than what I started with. So I'm going to start with the x squared term. I should have 2x squared minus 1x plus 2 with no remainder. You could also make this 2x squared minus x plus 2. Either is correct. So now let's flip to the next page, simplifying, multiplying, and dividing rational expressions. These notes are the 6-3A notes. They belong on page 75. It's about simplifying, multiplying, and dividing rational expressions or expressions in fractions. This problem is a simplify. This problem is a multiply. And this problem is a divide. So in the simplify examples in the set of notes, there are 2 steps. The first step is to factor. The second step is to cancel out all common things, cancel out all common factors on the top and the bottom. So on number 6, I'm going to go figure out all of the pieces that are in them. So I'm going to expand it. You do not have to do this, but it's easy to see what to cancel out if you do expand. So this is a 2 times an x times a negative 2 times x squared, so x times x, and then x cubed, or sorry, y cubed. So that's all my pieces on the top. And then on the bottom I have negative 3 times x to the power of 4, so x times x times x times x. And then y to the power of 4, y times y times y times y. So I'm going to get a different color pen so that you can see, or I guess a marker, so that you can see what it is that I'm canceling out. So I'm canceling out anything that's the same on the top and on the bottom. I noticed that these negatives can go, so no more negatives. I've got a pair of x's that are gone. These x's are gone. These x's are gone. These y's are gone, y's are gone, y's are gone. So what I'm left with is 2 times 2 on the top. That's 4. And I'm also left with, nope, that's it, 4 on the top. Then on the bottom I'm left with the 3, not the negative, but the 3. An x on the bottom and a y on the bottom. That's it. I could have just as easily looked at this problem and said, okay, the negatives are going to become positives. I have x squared and x on the top, so that's x cubed. That means that if I cancel it out with this, it'll leave an x. And then y cubed over y to the power of 4, that'll cancel out, and that'll be a y. So I could have also done it that way. Either way is acceptable. Moving on to number 7, if I multiply, the steps for when you multiply are the same. So factor everything and then cancel out common factors. So factor and cancel. By the way, I'm getting these directly from page 75, my notes. It has the steps at the top of every section. So I'm gonna factor what I see I can factor. So a minus 7 cannot be factored anymore because it doesn't have a squared. A plus 5 cannot be factored anymore. It doesn't have a squared. It's just to the first power. This can be factored. So I see a trinomial. That means I'm going to use magic numbers. The first term is a squared, so that means that the first term in each of these can be a. And you can write out your magic numbers if you want to pause the video and do that, but I'm going to do them in my head. So I need to know what multiplies to be 14 and adds to be negative 9. Well, 2 and 7 multiply to give me 14. But in order for them to have a negative sum, they both need to be negative. So that's my factored form for the denominator. And then in the numerator up here, I do have an a squared term. So I think since it's a binomial, what can I take out of both of these? Well, I can take out a 10, and I can also take out an a. So I'm going to take out a 10a. 10a squared divided by 10a is just a. And minus 20a divided by 10a is just minus 2. So that's my factored form for the top. I'm going to draw a big rational bar, my fraction bar, and I'm going to put all the factors on top and all the factors on bottom and cancel out what I have common factors of on the top and the bottom. So I've got a minus 7, I have times 10a, and I have, a minus 2. On the bottom I have a minus 2 times a minus 7 times a plus 5. I'm going to cancel out things that I have that are the same. So I see an a minus 7 on the top and the bottom. I have an a plus 2 on the top and the bottom. And I don't have anything else that I can cancel out, so that means that the rest of this needs to show up in the answer. So my numerator has a 10 and an a in it, and my denominator has an a plus 5. The last one that we need to do is the division problem. And so on the division problem, we had one extra step. So before we get to factor and cancel out, we have to rewrite. If you're familiar with keep, change, flip, then you can do that. But some of you just know that anytime you see a division sign, the fraction that's right after that you flip. So you need to really multiply by the reciprocal. So what this becomes is 6x squared over 6x cubed minus 6x squared times, and then the reciprocal of this, which is x plus 5 on the top and 1 on the bottom. So we have now rewritten. We need to factor. So I notice that 6x squared cannot be factored. There's no extra anything to take out. X plus 5 can't be factored, 1 can't be factored, but this bottom one can. So I think, it's a binomial. What's the greatest common factor that can come out of both of those terms? And the answer is 6x squared. So 6x cubed divided by 6x squared is x, and minus 6x squared divided by 6x squared is really minus 1. So this has turned into this. So I'm going to rewrite this just like I did up here with all the factors on the top and all the factors from the bottom on the bottom. 6x squared times x plus 5 and 6x squared times x minus 1, and you can really put times 1 if you want, but you don't need to. I notice that my 6x squareds are showing up on the top and the bottom, so those are gone. And all that remains here is an x plus 5 on the top and an x minus 1 on the bottom. X minus 1 times 1 is still just x minus 1. So that's why I kind of ignored the times 1. So now we're going to scoot down and go to the add and subtract rational expressions. Adding and subtracting rational expressions is the 6-3b notes. They should go on page 76 of your notebook. There are several steps here. We do need to factor everything completely before we move on, but the most important thing we need to do is determine a least common denominator. That least common denominator needs to be made up of all of the pieces of all of the denominators for the problem. So in number 9, I have this denominator, and really I have a denominator here too. This is written as over 1, which is not going to make a huge difference, but we're going to write it anyway. So if I factor first, I notice that I can take something out of here. So each one of these is divisible by 2. So 2 is going to come out. This becomes x squared. This becomes minus 6x. And this becomes plus 8. And I still see a trinomial, which means that I should be able to factor by using magic numbers. So again, you can pause the video and you can try it out on your own, or you can do it in your head. So I notice that the first term is x squared. So x and x are going to be my first pieces here. I need to think of two numbers that multiply to give you 8, and they add to give you negative 6. 4 and 2 come to mind, so I'm going to write those down. And they need to have a negative sum, which means that both of them need to be negative. That way, when you multiply them back together, you're still going to get a positive answer. So that's my new denominator. So I'm going to go ahead and rewrite this. This is x minus 8 over 2 times x minus 4 times x minus 2. That's what this used to be. And then plus 2 over 1. Not very exciting. So my least common denominator is my next step. I need to come up with one of all the pieces of all the denominators. So a 1, but multiplying by 1 doesn't do anything, so I'm not really going to include that. A 2, an x minus 4, and an x minus 2. So these are all the pieces of the denominators. Step 3 is to multiply each rational expression, top and bottom, by whatever's missing to have that common denominator. Well, this is already the least common denominator, so I don't need to change this. But I do need to change this. This on the bottom needs to be my least common denominator, so I'm going to multiply by 2 and x minus 4 and x minus 2. And what I do on the bottom, I need to also do on the top. So now I'm allowed to combine these as one single fraction with the denominator that's the least common denominator, the LCD. But I need to add the numerators. So I've got x minus 8 plus 2 times 2 is 4 times x minus 4 times x minus 2, which actually we knew x minus 4 and x minus 2 together multiplied to give us this. So I'm going to go ahead and rewrite that, because this step requires that I combine like terms. So I've got to multiply everything out. So I'm going to go ahead and distribute. This is x minus 8 plus 4x squared minus 24x plus 32. I'm sorry, I'm running into that line. Over 2 times x minus 4 times x minus 2. There. And I do need to combine those like terms. So I see 4x squared. So there's my x squared term. Negative 24x plus x, so that's minus 23x. I'm just combining like terms and crossing them out as I use them, so I don't reuse them. And then 32 minus 8, that would be negative 24. And my denominator is still 2 times x minus 4 times x minus 2. So now let's go ahead and flip to the back side. We've got one more practice problem like that, and then we move on to solving rational equations. Okay, so in number 10, first I want to factor, and then I want to come up with the least common denominator. The only thing that I can factor here is this. They're both divisible by 4. So I bring out a 4. What I'm left with is x minus 8